Hello. So finally, great. So before we start with the session, the next frontier Microfrontends, I have a good and a bad message for you guys. The good message is that the preparation for this talk was fairly easy. I didn't need to, let's say, walk around and practice to keep eye contact and everything. I do what I do every day, 19 hours, stare at a screen. The bad news is that the old saying, the man who waits long enough in front of the barber shop gets a haircut. Well, I don't know. At least at this point in time, it's not true. So you need to bear now with my with my styling for the circumstances we're currently facing. Nevertheless, let's jump right into the topic. One remark, the Q&A is quite open. After each slide, I will make a small pause to check if there are any questions in the Q&A channel. I would then answer them right away. Questions that I don't answer, I will answer in the Discord chat after the talk. So with that being said, let's jump right into the topic, Microfrontends. My name is Florian Rappl. I'm a solution architect at SmartPiot. We are dealing mostly with concepts, solutions, and architecture in the space of digital transformation. We also historically deal a lot with IoT and embedded computing. And these days, I'm quite busy in architecturing and writing concepts for creating distributed web applications, mainly digital service platforms. I also work a lot in open source environments. I'm a Microsoft MVP for development tools, and well, I have a lot of projects, especially in the .NET and the JavaScript / TypeScript space. With that being said, let's not be bored with details about my person. Let's jump right into the topic. Let's start with a motivational example, a standard, let's say, system architecture as it is rolled out like sand on the beach these days. What we usually see is that we have a couple of interlinked services, interlinked with whatever technology, right? Maybe a service mesh that orchestrates that, maybe direct communication, whatever it is. There's some services. And we usually call them, let's say, microservice architecture, even though there may be nuances of that, but let's just go with the popular terms. So usually these services should be scoped around business capabilities. One of the advantages is that they're usually developed by autonomous teams. They have their own development and deployment lifecycle. The services are at best really loosely coupled. So even that the service A that has maybe some interlinkage to service X is not really talking to it directly and doesn't know it, and we can mock the services. And one of the other advantages they say about microservices that they are technology independent. Right? I mean, we don't want, of course, to have, let's say, 15 services in 15 technologies, but nevertheless, if there is a special technology that allows us to write one service with better performance or in a faster time, we go for it if we have the expertise, of course. Now, looking at the front end, we usually just have a single front end solution that, of course, has some motivational aspects to it. Right? I mean, we will see that a single front-end solution comes with some benefits, as a single back-end solution will come with benefits too. A single front-end solution is a monolithic architecture, but it comes with integrated and consistent user experience, which is quite important and crucial for a front-end experience, right? So you don't want that you go from one page to another page, and on the first page, the button is in green, and on the second page is in blue, even though both are, let's say, the primary buttons. You want to have, let's say, one UX talking to the end user, and that usually results in that the front end is developed by just a single team. And if we have now this large monolith, then we have larger deployments. And if we have larger deployments, we face, of course, some issues, which is what brought us in the backend to develop an architecture as we see here. Now, regarding the operational aspect of this, if we now look at our CI/CD pipelines, they may look as follows. We start, of course, from our repository. We check it out. We got the code. Some compiler runs through it. And then we place it on some archive. It is some artifact, and later on we can release this, for instance, by creating a Docker image and pushing it up to some service. And we do that for all our pipelines. So each service is a pipeline, and we always do the same thing. The technology, of course, of the compiler may change, but it's always the same thing. Now, these are all our backend services. And then we have the one front-end example. Maybe here, instead of using something like C# as a language, we use Webpack, and we only have, let's say, front-end resources. We packed it in a Docker container using an Nginx as a base image, and that's it. Maybe the whole thing runs in a Kubernetes cluster, who knows, right? But that's one example how it may look like. And we see these architectures really popping up everywhere. And they are not bad. I mean, they have, of course, their cons, but there are reasons why we do these kind of architectures, and they work quite well. Now, looking at some of the, let's say, larger tools, the larger web apps we're using every day, we may look at something like, for instance, the Azure portal. Yes, I know that changed over time. I didn't swap out my image here. But I mean, the basic idea of this application is still the same. So we have a large dynamic web application that loads data and has really dynamic functions that are tailored to the end user. Like, for instance, I can be a Microsoft employee and I have access to some of the new preview features. Then I would see them in there. I would see maybe new tiles in there. I would see new kind of menu items on the left-hand side. And I would have completely different functionality. Now, of course, we can ask, how is that created? And is that, let's say, a large monolith? Do they also have one massive rollout? How are new features entering their space? What are they doing? Likewise, the same holds true for Azure DevOps. That is extensible. We know it because we can write extensions for it. And there are certain pieces of functionality that also, let's say, lazy load, but only load when, of course, I'm a user that has this capability. Like, for instance, I only see test plans if I have, let's say, test plans activated and if I have a certain subscription. Now, of course, we can say, oh, this is Microsoft. They are huge, right? So they can have tens or hundreds of engineers on this topic, if not thousands. And then, of course, they can deal with it. So what can we do with a team of, let's say, just 5 to 15 engineers? Well, it turns out we can do something. So, for instance, a German company we work together with created a digital service platform, and they use such a modular approach for the front end. So they have really tailored functionality for the end users. Like, for instance, some users may see the software center because they have a machine where they can download the software for. And then suddenly they see in their service entry on the navigation, they see a software center, and they also got access to that page. Right, then the same holds true as we've heard beforehand. We just want a new feature, it can just be deployed. So the answer to all of that is Microfrontend architecture. Well, we are on a Microfrontend talk. So what is Microfrontend architecture after all? And how can we set up appropriate Microfrontend architecture to really bring up applications that have the scalability of, for instance, applications like the Azure portal? So we start again with our backend. Now, in a simplified view, let's forget about the dependencies here and all that. We have just some services, let's say service A, B, C, D. And all we want to achieve in the Microfrontend architecture is that we can mirror that somehow in the front end. Now, not every service needs an associated front end, right? And the picture may change that, let's say, front end C has a dependency on service C and service D, so it's not always a one-to-one. But for simplification, let's just say it is like that. The simplest way to achieve this is instead of having just services that return, let's say, JSON and have an API, we can have something that already renders it, right? So instead of having web APIs here, let's say in terms of ASP.NET Core, that we actually write in Razor templates some HTML and serve this HTML. So we have microsites And then the question is, of course, how do we combine them to the end user? Because we don't want to say, yeah, by the way, we have this web app, but in order to use it, you need to have these 20, 25 URLs. That's not the idea, right? And so already having these, let's say, boxes that are just floating there, that will not work. We will at least require some level here of integrating that. Now, there are certain implementation patterns for that. And depending on which direction we want to go, we need to use one or the other. I wrote a small article about that, but I don't want now to go in all the patterns, at least the patterns I'm aware of, and the patterns that are quite popular. I just want to mention two of them, and then I want to go on and, well, try to motivate a different approach from microfrontends that, in my opinion, is like a sweet spot, because it would work in most cases where you say microfrontend makes sense. Now, looking at this first pattern here on the left-hand side, what you can see is that we have exactly the scenario I described. You have microsites where each one renders an HTML fragment. And then you use a reverse proxy, so it can be as simple as an Nginx, can be also Varnish or anything like that. And this one brings together these fragments and then serves it, of course, to the end user. The big advantage of this approach is, of course, that it's all server-side rendered, and it works when the user doesn't have JavaScript. It should be quite fast, right? But the disadvantage is also quite there. How do you debug this without setting a reverse proxy locally? How do you make sure that this dynamic stitching works without giving the reverse proxy too much information? And so this pattern that was, I think, mostly introduced by Zalando, but others also came up with it. Yeah, didn't really succeed because the complexity is just very high. And in the end, people say, oh, okay, there's a reason why we have our standard APIs and why we want to decouple frontend from backend. And yeah, so other patterns emerged. And so another extreme is, and there's certain layers in between how we can go, is that we still may have one server that serves, let's say, an HTML file, but it also includes a little bit of JavaScript as a kind of a glue code. And then this JavaScript starts and it talks to the APIs of other servers. And what it receives is other JavaScript files together with the data. So the data is really just the plain data, but the JavaScript now determines how to render that kind of data and, of course, where to render it to. So, and then it results, of course, in a stitching as we see in this box here. So we have now our page with our fragment that should be inserted. We click somewhere, JavaScript executes, it mounts it, it renders this part in there. And so we complete the cycle, we stitch it together now in the front end. So far, so good. Now, what we are after is kind of the best of both worlds. So we say, well, what are we really interested in from the microservice side? And which parts of the monolith do we want to keep? And how do we bring these two together to have something like a sweet spot? Certainly, it will not fulfill the need for everyone. I mean, we are not only in computing, but it's always in life like that. You can't please everyone, but that's not the idea here. The idea here is really to find a sweet spot that works in most cases and comes up with a really good solution in these cases. And what we are after is therefore a modular distributed web application. So what are the key aspects of that? First, our business capabilities should be modeled as modules. So think about it like that. You have a page with, I don't know, showing user profiles. That's now a business capability that should be in its own module, should not be in your main application. Now another thing comes up, you want to see, I don't know, audit logs, another module. Something else, another module. So you always package it up and you split it by the domain. You would not split it by, oh, here's my whole navigation for my front end. Here's all my pages. No, that's not the way to do it. You also don't split up your microservice backend with here's my API, here's my data, and here's a service that deals with the business logic. That's not how you split it up. You split it up by the domain, and that's quite important. So keeping the functional domain and encapsulating that in your modules. Now the modules, they shouldn't know each other. They should be loosely coupled towards each other, but also towards the main application. So you don't want to have a strong coupling here. And the first thing why you don't want this is you want to enable dynamic loading. And that doesn't only mean lazy loading, that you just load it when you need it, but that also means that you just want to load what is accessible for the user, which means, let's take the example beforehand, user profile, audit log. I'm a standard user. I want to see my user profile, so that should be loaded. But the audit log, well, maybe that's just for an administrator. That should not be loaded, right? I mean, why should it be? And if there would be a strong coupling between the two, that is impossible. But now, since they shouldn't know each other, it's very, very likely that we can do that, right? Because, I mean, there is no dependency whatsoever. Still, some things should be shared. For instance, an architecture foundation. So if I look in one module and if I look in another module, I should not say, oh, this is, there are two different species that wrote that. I should say, okay, yeah, that looks similar, right? Even though this one thing deals with a completely different domain entity, they are, at least on a high level point of view, identical. They do the integration the same manner, and that's quite important. We want consistent UI and UX. Now that also flows into the shared architecture foundation, because for instance, in the shared architecture foundation, if we say for components, you have this shared component library and you are urged to use it, then the consistent UI, UX is already one step closer to be realized, right? If we don't, let's say, give out this component library, if we say, oh, just come up with your own styling, then this is impossible. And it doesn't even need to be a component library. It can be just, let's say, a pattern library where you say, we don't give you the CSS, but we just give you how it should look like. That is already sufficient. Of course, that will result in some duplicates, and of course, due to implementation effects, also some inconsistency, but that's the minimum foundation, that at least two modules have the same UX behind it from the idea. And that was one of the advantages of the microservices too. In the end, it's important to be developed by independent teams. It can mean that you start, of course, with just one team and you say, oh, yeah, we want to have this Microfrontend architecture because we know that later on there will be more teams be onboarded and they will also deal with it. So it can start with just a single team and that's totally fine. But you want to have the ability that an independent team can work on just one module and ship that completely autonomously. If you have this, then I think you're already in a far better state. So let's wait a couple of seconds if there are any questions so far. I don't think so. So let's just continue. Right, distributed. That's the important word here. Really, distributed means can be developed independently and you don't need to share access, for instance, to your main repositories, and can have independent deployment pipelines. Now, what's the proposed architecture for this? We know already that it will not work if we really just mirror this thing, a service with a front end, and they are just standing there in the wild, loosely only exposed via the URL. That will not work. So we need some kind of a common layer. And we say this is the so-called application shell. And the application shell component surrounds these modules. And it also brings some common things, like for instance, shared libraries. Yes, shared libraries are a problem, but no, you should have at least one or the other that's really crucial for your to gain performance, right? So let's say you wanted all your microfrontends use React. I mean, it's a possible choice. We can also go and say, let's leave it free, but let's say for a moment, all of them should use React. why should every module package the whole React and maybe even React DOM in there, which is another, let's say, 100K? You don't want to do that. It's not only the 100K and that you need to deliver that over the network, it's also that the browser needs to evaluate it. And of course, it's not really good in sense of that you can have one render tree. So in this example with React, you want to have it shared, even though, of course, that will have an impact because you cannot just upgrade that. You need to make sure that you only upgrade that there are really no breaking changes for all your modules that you have. And that, of course, imposes huge responsibility. But still, you need to find the right balance between having shared something and, well, leaving the modules up to their own choices. The pattern library is set, but again, that's also shared library. So be also aware that upgrading here with breaking changes may not be good, but there are always ways to work around it, and there are always tooling, etc., to ensure that the system is working. So I'm not going into that right now. All I want to say is we think it's a sweet spot, but it doesn't mean that this is a silver bullet. And then we have, of course, our individual modules here. So now they are not applications. You see here the package icon. So the application icon changed. This is not now a microsite, it's rather a module. And in order that this module lives, it needs the application shell. So it can only run within the application shell. All right. So much to the theory. Let's see how that may look in a real user experience. All right. What we see here is one of our demo portals. This is a very simple React application, and we can just load it. Let's see if it all works. And it comes with some aspects. It comes here with 2 tiles. I can click on them. There's some lazy loading. This is some kind of a timesheet. It just loaded. Or here's a vacation planner. The same holds true here. I click, it loads. There's some data in there. It's all cool. So far, so good. Now, when this whole thing loads, let's let it load. It loads this application shell. But as said, the application shell is not directly coupled to all the modules, right? So how do we get the modules? As we will see in our architecture, we need to connect to some kind of a service that we call feed service. So this thing says, oh, the following modules should be loaded for the current user. And in this case, we load 3 modules. So we load posts, timesheet, and vacation. So here's vacation. Pretty much, I mean, one part of vacation. It also has the page, of course, but let's say this comes from vacation. This thing comes from timesheet. And then we have entries like, for instance, sample. That's coming from posts, as we will see. We also have other things, like, for instance, here's my vacation. Now that's also related to vacation. But what we can see already in here is that a module that comes doesn't really expose itself just in form of, let's say, pages, but it can expose itself in whatever manner. It can say, hey, I want to have some part of the screen real estate on the dashboard. I want to have an entry in the footer menu, or I want to have an entry in the top level navigation. That's all possible. Now there are other things possible. Let's turn on here save data. So what this extension will do, it will in my browser tell the browser to send one additional header, which is save data. And if we do that, we now we'll see that there is no sample link here. So what happened here, let's look at our feed response. We now just get back 2 modules. That's great, right? And all that was done is save data on. So again, let's disable that. Let's load it again. Now save data is not sent. And we have again the sample link here. Because we only load this one module, which is a block module, believe it or not, with containing some posts. If we say, oh, we only want that if the user is not on a save data plan. So you can deliver modules only when you say, oh, certain headers are there or not there. In this case, I guess it's a practical use case of saying You can also switch out, of course, modules and say, oh, I give a user the full module when the user doesn't have a saved data on. But if, for instance, through a mobile phone, saved data on is sent, then we just send a reduced version. It comes with the bare minimum and really works just on with minimal data requirements. And it's a completely different implementation, maybe, or another version. So that works, but there are other things too. So this feed service really can have some logic that I don't need now to write, neither in my application shell nor in my modules. So no module says, oh, I need to now evaluate that header. The application shell also doesn't say anything about evaluating that header. It just sends it, right? It's just the browser that sends it. And likewise, what we can see here, I send a query here. So this user type normal, and we have another rule that just says if the user type is boss, we don't deliver the timesheet, because apparently the boss doesn't have any time tracking, any vacation allowed. So in this case, what we can now see is that there is no vacation tile. And if we look at what was actually received, okay, still the posts, and here's the timesheet, but there's no vacation. And important, vacation also delivered the footer entry, and that's also gone now. So we didn't load the module, and that had a huge impact now on how the application shell is actually displayed to the end user. And if we want to see how that works, here's our public service, our feed service. And for the posts, for instance, we can look at the rules that are set. And we just see that it has a header rule that will essentially block if that is hit. And we see that the header is sensitive to save data, and it just compares if the value is on. And that's it. So quite simple. And we want, of course, to improve, let's say, the editing experience in there. But at the moment, it's just a simple JSON. But it's mostly to illustrate the point, right? So it's not about this UI or that particular service. You can write it in any kind of service. It's just that this kind of rule engine is embedded in the feed service, and it just makes the microfrontend so much more usable, because it's not just for developers. It really has a business impact. You can now say, you make a staged rollout. You only go with beta users, then you go with one market, then you go with all markets. You can say one thing is aligned with the permissions on the backend already, and we only deliver it if it could be activated. So there are many possibilities, and they're all just established because we already modularized our front end accordingly. So again, let me clear the rule. We send the normal user, and we see now again these aspects are there. That being said, that's the user experience we are after, right? So how can we establish that? And I think some of the parts we've already seen, but let's have another look at it. So what are the challenges?
Florian, can I interrupt you for a second? We have
Sure.
one question. Maybe you want to take a look at the Q&A area.
Thanks. Let's have a look at the Q&A area. And so I cannot move that down, but I can. Bear with me here. It wouldn't make sense to use different technology. Oh yeah, okay. So the question regarding different technologies. Yes, so you can mix technologies in microfrontends, and in my opinion, every good microfrontend solution should have a capability of allowing that. But that being said, as with the backend, your aim should not be to have as many technologies as possible, but also to reach a certain kind of sanity point there. Right, so if I start my microservice backend, I'm also not saying, oh, this service I do in that technology, the other service I do in that technology, and the third service I do in a third technology just for the fun of it. Because thinking about a team, you may have a major experience in that team, and that maybe, let's say, is React or is Angular. And you should strive for that, because let's say every developer develops its own microfrontend, and everyone just says, oh, yesterday I heard about Vue, let's use Vue. Oh, I heard about Svelte, let's use Svelte. Now that's all great, but what if that one developer that wrote it is on vacation or left the company, and now you're up there to solve a bug? That's not much fun, right? So unless there's a really good reason to choose a different technology, I wouldn't do it. Now, there are certainly reasons why you want to have different technologies. For instance, migration paths are just super simplified. If you have the capability of introducing multiple technologies, you can still say, I have React, I want to go to Angular, for instance, and I can still use React and one by one change my React modules into Angular modules. Now, at this point in time when you start, it may not be the ideal user experience because, I don't know, React uses an older version of your component library or its own version, of course. Of course, it will come with some overhead when loading, etc., etc. But still, it would work and it would allow you this migration path. So my personal point of view is avoid it when you can, but still include it because it will just give you so much more freedom. And when I talk about microfrontends, I'm not about this side of microfrontends because for me, that's just, really technology driven. But for me, the important part is that you also deliver some value to the end users. Because otherwise, I mean, why are we getting money for this? We are getting money also to deliver some value to end users and not just to play around. I mean, playing around is great, but you also want to deliver value. And this value you want to achieve in a certain fashion. And I think this is where microfrontends can actually help us. But it's a complicated topic because on the back end, of course, there's not so much penalty besides, of course, the obvious knowledge gap that may appear in different technologies, but there's not so much penalty. On the front end side, there is definitely penalty because it all comes together in one machine and you need to take that into consideration. That machine may be a mobile phone and it may be an older mobile phone and it may cripple the experience. So keep that in mind when choosing, should we now introduce another technology or not? But there are certainly multiple aspects in that discussion. And yeah. With that being said, principles and challenges, and we will see that the multi-framework approach will also come up here. So first of all, first-class development experience. It should be possible that you have your modular front end and just picking up on the case described beforehand. You want to fix a bug. Well, it should be fairly easy to set up a development experience. You should just clone the code, npm I, and there you go. You shouldn't need to read multiple pages of documentation and say, oh, now I need to go to that URL, change something in local storage. Now I can, I don't know, debug this thing online. It should just work on a local machine and it should just be set up within minutes. Still, we want a comprehensive development tooling, which means things like I want to create a new module for my application shell that also should be as easy as running as one single command. So scaffolding, including, oh, I want certain patterns. I don't know, maybe an editor config, maybe a prettier setting, maybe already some components and guidelines. I want it already in that solution when I scaffold it. That should all be possible in such a solution. So really giving a toolbox to the developers of your modules that should be possible from the perspective of the application shell owner. You want to have a distributed development of modules, as already said, which means you can have isolated repositories, each module in its own repository, completely independent build pipelines, so everything just distributed. You can even say, oh, by the way, my frontend is extensible and I give out to the world my SDK, and so everyone can potentially develop their own module for your application. So not only teams within your organization, but even outside. As said, it will appear here, so support for multiple frameworks should be in there. And support doesn't mean that all the frameworks are supported out of the box, but it should be possible that, you can say, oh, we need now support for Vue, and we don't have it. It should be fairly easy to establish that. I think that is also quite important for, as said, things like migration paths. And backend services, to make it really round, as we've seen, something like this feed service is crucial. And we want to have, let's say, support or basic patterns to create that. And if we have that, and if people can, let's say, use it, then we are happy. So solving these challenges and incorporating these principles, that is what we are after now, using the following architecture. Now, as we've seen from our demo, we are now a user on our standard client, the web browser, and we now hit an endpoint somewhere. What's delivered to us is the application shell. And that needs, in order to live really, to come with functionality to gather the modules. And these modules, they are then retrieved from a feed service. But that's just the dynamic part of the story, right? There's also a static part, and the static part are the assets from each module. So assets like JavaScript, CSS potentially, maybe some images, who knows, maybe a video. All these things that you say, that makes now a living front-end module. And there is more than just one JavaScript file, because we've seen there's lazy loading. So maybe each page is its own JavaScript file there. And what we can do is we can just put them on a certain kind of a shared storage. Let's call it a module storage in this architecture diagram. Now, there is also a tooling aspect to it. I'm now a module developer, and I now need to somehow publish my created module. And so we should provide some tooling that enables just, publishing to a feed service. And that publishing can work on a local machine, can work in a CI/CD pipeline, can work wherever, right? The only thing is, of course, that you either know the API of this feed service, or you have this tooling that does the communication for you. That being said, many things that I just described remind us of a certain, let's say, drive or concept, some elevation of the whole microservice topic. And what I'm talking about is kind of a plugin architecture, or what was then phrased serverless. So if we think about it, and we will see that in a second, serverless also gives us kind of an application shell. It gives us a runtime that's shared, and it places now all our serverless, our functions, in kinds of modules. We even, if you think of AWS Lambda, we even publish them as a standard tarball. If we think about Azure Functions, of course, it's purely the same. And if we develop it locally, there's an emulator, just saying, but we will see that in a second. So what we usually call this kind of architecture for microfrontends, siteless UIs, or just siteless. Because after all, you write something like a website fragment, but you don't have a website running somewhere to expose it for you. Instead, you get a runtime somewhere set up, and that runtime you essentially use, that's your application shell. So what is serverless to microservices is siteless UIs, or serverless functions is siteless UI to microfrontends. So that's a kind of a distinction we usually put in here. Not to confuse you too much here, it's still microfrontends. We just think it's more close to what serverless is to microservices as it is to microfrontends. So also for serverless, development happens in a standard IDE. You can do it in VS Code, you can do it in Visual Studio, you don't care, it just works, right? Because after all, it has the same runtime. You debug it usually locally in kind of an emulator, and that's the same what we do with the approach we've seen. So you essentially get your app shell locally, and then you use it as a kind of emulator. You also have this loose coupling. So if you write multiple of your Azure functions, for instance, you will not say, oh, there's this other function. Maybe there is it, right? But you make it then decoupled via, for instance, some environment variables and all that, and decouple it via the routing engine usually, right? So you don't actually say there's this other function and you need to go explicitly to this instance. It's not like that. You usually come up with some kind of a manifest when you want to publish it. Now for our microfrontends, that means we need to tell it somehow where it needs to hook into, right? Does it register a page? Does it want to have, let's say, a part of the dashboard? Which menu areas does it want to be in there, and what component should be in there? Like what you do with your routing when you say, oh, you got this post endpoint or this get endpoint, you have some kind of a manifest, and the same holds true here. And if you deploy it, then you deploy it without the runtime. So for a microfrontend module, you also don't put in the app shell. And for your Azure function, you also don't put in the whole runtime. You just deploy this one little library, and that's then actually hooked on dynamically. And this dynamically hooking on, that's actually done instantaneously. So you just got it available online. It's even that fast that you can edit it in the Azure portal, and you just hit check, and it already runs in the Azure infrastructure. So very, very fast and rapid development cycles, which makes this ideal for writing just some glue. So let's check out the realized architecture. And in order to do that, we've seen already the demo that used that. Essentially, I want to come up with an open source project we started to actually illustrate this architecture. I mean, we now set it up at a couple of clients in the past, and then we saw this architecture is so good. We want to really make an ecosystem around it, make it open source from the core as a kind of a reference for it. But all that I said, you can do on your own, of course, and you can also use the open source code to just, learn from it or get certain parts and use it as a reference, really. But that was our idea when we created this, and we called it Piral. So kind of a thing of a portal that goes really and allows you to do these kinds of application shells with modules in a simplified way. All right, so how does the picture change now with Piral, and what did we use, and how do we now, for instance, leverage Azure? But you can leverage any cloud, even though we're in the global Azure bootcamp. Of course, I should say that this works pretty much on any cloud, but we are Azure specific here. So our CLI is a standard Node.js application. So that's the tooling you get. That's also what you know of other, let's say, front-end specific frameworks or tools, that they're always written in Node.js. Gives you cross-platform capabilities and makes this thing quite easy to install and use. Now, what you can do with your Piral instance is, since that's just a standard static web app, that's it, that lives and is dynamic on the client side, even though, of course, you can do things like server-side rendering and all that, but let's exclude it for a moment. You can go ahead and host it actually on Azure Blob Storage as just a container, website container, and that's sufficient. You can have a CDN in front of it, and there you go. Your scaling needs are certainly met. Regarding now getting your pilots, what we do is standard Azure DNS. We have everything orchestrated in Kubernetes. Our feed service lives there. And so after all, we just find the pod instance, and this thing will deal with your feed response. Now, all your feed service you can write on your own feed service. We have also a sample, but we have this reference thing that you've just seen that has a small UI too. And then regarding where do we store now the static part of the pilots, so things like the JavaScript, CSS and everything, well, that we put on an Azure CDN. So in the end, just some blob storage too. And that's about it. So it's a really simple architecture. You don't need, let's say, 15 services to make it live. And most of the things give you scaling out of the box, right? So feed service, you can, of course, discuss, and you need to make that scalable and reachable and geo-distributed potentially. But that aside, all the rest, since it's just static resources, you can scale really well and really simple. And by the way, all the assets are versioned, so which means you can cache them indefinitely on the front end, which is quite good, because after all, a first time use may be, let's say, slower than you want. However, subsequent users are then very fast, but still, first time users, I think, still quite a decent shape. So with that, let's have a look how the application shell development may look. And I just want to touch that briefly, because I don't want to, sorry, wrong window. I want to spend some time on deploying also something. That's the code from the demo portal that we've seen. It starts with a simple app TSX. It doesn't do much, checks for authentication, and either, provides you with a login screen, or just has a spinner and starts loading the whole thing. And we could dig into the code. There is not much magic. We have things like a standard layout that comes with notifications, a header. This is the top bar. That's it. So there is no magic. We just say, oh, we have these components like a layout or a dashboard tile and whatever we want to define in here. and can use standard React for all of that. But then we have this one piece where we need to load these what we call pilots. So a pilot is a module in our Piral framework. So that's what are the usual microfrontends. And this is all done by just one function that you can write, and you can actually get your pilots from whatever you want. And in this case, we go against the feed service. And all we do here is we just fetch from there, read the JSON response, and this response, as we've seen in the browser, it has an items key, and this is where all the pilots are defined from a metadata point of view. So where is the root module? And that's pretty much all. And the magic with the additional parameters that we put in the query, well, that was user defined here. So it is completely up to you what you transport to your feed service, or in this case, of course, to our feed service, completely up to you. And that's about it. So that's just a static web application that is built using Parcel. It can be built also using Webpack. Doesn't matter in the end how you build it. It just gives you a bunch of files and that you can just put up on your static storage space. Can be a Dropbox too, right? It just works. And that's how you develop your app shell. Again, it can be more complicated for real world application, and you may have other requirements too, but in a nutshell, it's as simple as that. Now, the development approach that we saw initially was, let's say you have your services, you have a single front end. That is not really the way we want to deal with it right now, where we have one front end team, maybe multiple backend teams. We can now change this. And we could have different kinds of cutting it. So one possibility is that you still have one team that's responsible for the application shell. And then you can have full stack development teams. So teams that say, oh, I got a service and that service also should expose something in the front end. This same team also makes a front end module. Now that's of course just one way of cutting it. You can of course draw another line in here. You can cut it as you want to. So it's quite nice that it gives you this flexibility of cutting now your teams. And we've seen great success with these full stack teams in some projects. But we've also seen success with let's say, mixed approaches where there were sometimes full stack teams, sometimes teams that were just responsible for a couple of front-end modules and also a couple of backend modules, another team, etc., etc. So it just gives you another dimension of cutting, which I think is quite nice.
Florian, we have one question that would fit in nicely. I can read it to you.
Yeah,
what
please.
Sort of branching strategy you recommend when developing microfrontend by independent teams, especially for shared module, GitHub sub-branch would work here, question mark. Maybe you can talk a little bit about that.
Yeah, I think it really fits in nicely because I just wanted to highlight now how our deployment pipelines change. And maybe let's take that first, and then let's have a look at the branching strategies. So we've seen that each service had its own pipeline. Now we can have an associate pipeline now for the front end too. Keep in mind that this Git symbol here may be the same repository, and you may have then either, two subfolders or something like that. Where you say, this is my service, that's the front-end module, but they can also be different Git repositories. That now depends on your cutting, and also depends, of course, how that team that is responsible now for the different parts wants to handle it. It can also be all in one monorepo. So there is nothing bad with monorepos. They also have pros and cons. Now, that being said, and I will come back to the branching question in a second, so bear with me, please. You can have now one, or let's say on average one pipeline for the that mirrors essentially what you had on the backend in the front end. Now there's one crucial difference, right? It's not only that we use a different kind of let's say compiler, but our way of distributing is also different. Remember that we had a Docker symbol for our front end initially. Now we have for different modules here just an Azure blob storage. Well, this may also resolve into your feed service. However, in the end, it just puts it somewhere in a blob storage. So your target is essentially a blob. And yeah, we still have, of course, our application shell, and that you may still want to deploy as a kind of a Docker container. Maybe not. Maybe you want to deploy it, as said, on a standard Azure Blob Storage website. Now, regarding the branching is, we usually try to do the same for the backend as for the frontend. And we will see that in a second. So for instance, if you couple your branches to environments and you say, you have a develop branch, and that goes to my dev testing environment. You have a release branch, and that, or a master branch, let's say, and that goes to a QA environment. And then you have a release branch, and that maybe go to a production environment. If you have that on your backend, you should do that on your front end too, right? So in the end, for us, it's not so much about which branching strategy you choose, because, yeah, I mean, that is highly team dependent. Some teams like this one over the other, so granted, but it should just be similar to the backend one, because then you have just a single thing to care about. And what that gives you as a result is that you can see the same picture that you may see with your backend on your front end. So this is an example from a project we're in, and we have quite a lot of modules there. So I don't know, 20, 25 right now, and this portal solution is not that old, so it will grow certainly. And all of these modules, they are running through the same stages as the backend services. So we can see here, for instance, that the new module 21, that's already available in 3 environments, but not in production. So here we are still on 16. So we get the same view in Azure DevOps that we have on backend services with the front-end services. And yes, that one uses the old release model. You can, of course, use the new YAML-based ones too. So that's not a big deal. But the idea that conceptually it's the same as on the backend, that's key here, because then also product owner can reason about it the same way. And even though technically something else is done under the hood, it still mirrors the same thing. Yeah, and with that being said, I'm already slightly over time. I just want to show one more thing, and then I'm ready to close the session and answer the remaining questions on the Discord. So let's say we have the timesheet that we see here. So here are some fake data, so that's not coming from a real service, and we want to make some changes to that fake data. How fast can we deploy it? And keep in mind that thing here is live. So let me just pick the right thing here. So in here, I'm in my timesheet module, and this is a highly simplified module, so really just for demonstration purposes. And all I have in here, let me see, is this load data. So that loads my mock data, and here you can see it just places some timeout. And let's just add another thing here. Let's call that, I don't know, Azure. And it's like, let's make it just 5 of 6. So save it. Does it save? Slight delay. Let me go to the console, and all I have prepared here is a script called publish sh, but it's not much that's in there. I can show it to you in a second, and I call it now here is timesheet. So keep in mind you can do the same, of course, in a CI/CD, but just to keep it shooted right now, I would just invoke it. So let's hope I didn't make a mistake. It's building the thing, packaging it up, publishing it. Done. Before we look into the code, let's see that our change is really there. It's loading, and here is Azure. So we just published this feature. It's now online. The new version of the package is there. What is necessary to have this done? What's in the publish? Well, all we do here, and you see there's not many lines, most of the lines deal with some definitions of the things we use, is we go into that directory that we specified, which was timesheet, and then we call pilot publish. So pilot is from our tooling a command that you get on the command line, and then we just give it the API key and the URL that needs to publish it. In the end, we just remove the tarball that was created. We don't need that. So nothing fancy, and again, your CI/CD system can also use the same call. It's not much of a difference, but that's how fast it goes. You've seen it didn't take any 10 seconds, and yeah, you go. You got a new version of your module online. Concluding, we started with, let's say, Microfrontend architecture in general, showed a little bit of different implementation strategies, went on to see what we want to achieve for a modular web application, and then I showed this reference application for using this architecture that specifically for deployment purposes, I think has really some nice benefits. I'm open for any questions in the Discord. The slides I will also publish, and I want to thank the organizers for this great event. I know it's quite some effort to bring that together virtually, but thanks, and also thanks to all the sponsors that make it possible. Much appreciated. Bye.